Alright, so this video is going to be part 2 of finding the line that is the intersection of two planes. Okay, so in the part 1 video we kind of talked about how we end up doing something like this and the whole concept behind it, especially the part where we're trying to find the direction of the line. That was a concept that was a little bit tougher to grasp at first. At least it definitely was for me, so that's why I'm saying that. But now we can just kind of focus on doing the problem itself, now that we kind of understand how it's supposed to be done. So the first thing we need to do, for a line we need a point and a direction. We're going to find the point first, okay? We need to find a point let's find a point on the XY plane, okay? Let's see if these two planes intersect on some point on the XY plane. Maybe we get lucky, okay? And generally that ends up working out for most problems, okay? So we set z equal to 0 here. If we set z equal to 0, we get x plus y equals 1, and we get that x plus 3z, sorry, not 3z. We get x minus 2y equals 1. There we go. So if we subtract here, we get that we have a y minus negative 2y. That's going to be 3y equals 0. So y equals 0. That's what I'll circle right there. So if y equals 0, that means that x equals 1. And we already said that z equals 0 because we're on the xy plane. Okay? Just, having it on the xy plane, that's just going to help us find our point. So we end up with the point 1, 0, 0. All right? So now we need to find the direction. How do we do that? Well, we need to find the normal vectors of each plane, and then we just cross them. Okay, when we cross them, we end up getting a vector that is in the same direction as our line. So let's do that here. What's the normal vector for our first plane right here? That is 1, 1, 1, right? Just the coefficients on x, y, and z. Our second normal vector, it's going to be the coefficients on x, y, and z again, which is 1, negative 2, and 3. Now we just have to cross these, okay? So we have I hat, j hat, k hat, 1, 1, 1, and 1, negative 2, 3. All right, so now let's start off with our I hat. We have a 1 times 3, that's 3, and that's going to be minus, and negative 2 times 1 is going to be negative 2, so this becomes a positive 2. Then we get minus j hat. 1 times 3 is going to be 3. We have minus a 1 times 1, it's going to be 1. Then we have plus k hat times a 1 times negative 2 is going to be negative 2, and then we'll have minus a 1. So negative 2 minus 1. And this is going to be equal to 5i hat minus 2j hat, and then we'll have minus 3k hat. So we get the vector 5, negative 2, negative 3. And this vector gives us direction. Okay, so we now have the point and we have direction. We can do our equation. Okay, so that's going to be r equals, and you can also write this, I've seen this written just as the vector x, y, z. That's equal to, well, what's the position vector for our point? That's just going to be the vector 1, 0, 0. And that will be plus the parameter t times our vector for direction. That's 5, negative 2, negative 3. And right there, you have your equation for this line. That is the intersection of two planes. So a quick recap now. What we did was first we tried to see if these two planes are going to intersect on the xy plane. Okay, if they did, we need to find the point where they do intersect. So we set z equal to 0, putting us on the xy plane, and we found that these two planes actually do intersect at 1, 0, 0. Okay, we found the direction by finding our two normal vectors for these planes, crossing them to now create a vector that is orthogonal to both these normal vectors, and that actually is going to point in the same direction as our line. Okay, so we were able to use that vector that we got from our cross product and put it right in for our direction in our equation. Okay, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.